Decimal to hexadecimal conversion. To convert a decimal number to a hexadecimal number, we should remember this table so we can solve the problems in a quick way. Problem 1. Convert the decimal number 469 to a hexadecimal number. To do this problem, we use a method called a repeated division method. So here the required base is 16. So the base of hexadecimal number is 16. So we use this number 16 to do the repeated division. First we have to divide 469 by 16. So we get the quotient 29 and the remainder 5. Again take the quotient 29 and divide by 16 and we get the quotient 1 and remainder 13. Again divide the quotient 1 with 16. So you will get the quotient 0 and the remainder 1. So this process should be repeated until the quotient becomes 0. So here the quotient has become 0. So we should stop here. Now to find the answer, we have to take the remainder part and from the remainder we have to form the answer. So here we know that a hexadecimal number are numbers from 0 to 9 and A to F. So here we have a number 13. This number 13 does not fall in any of this. So we have to find the hexadecimal number for this 13. So we can refer this table to find the hexadecimal number for 13. The number for 13, the hexadecimal number is D. So for 13 it is, the hexadecimal equivalent is D. So the answer can be written as, this is the answer. So 1 is the MSB bit and 5 is the LSB, and the answer is written in this way from bottom to up. Problem 2. Convert 0.54 to the base 10 to a hexadecimal number. Here we are going to convert a fractional part of a decimal number to a hexadecimal number. So we use a method called repeated multiplication method. In repeated multiplication method, we use number 16 to multiply the given fraction part of the decimal number. So here we'll start with 0.54 into 16, that is equal to 8.64. So 8 is the integer part and 0.64 is the fraction part. Again take 0.64 and multiply by 16, we get 10.24. So 10 is the integer part and 0.24 is the fraction part. Again take 0.24, the fraction part, the 0.24, and multiply by 16. So we get 3.84. 3 is the integer part, 0.84 is the fraction part. So repeat this process until the fraction part becomes 0. But in this case the fraction part does not become 0, it keeps on going without an end. So at one point we will stop. So now we can find the answer, the hexadecimal number, from the integer part. So here the numbers here we find, as we know, in the hexadecimal number are numbers from 0 to 9 and A to F. So I said from the integer part we have to form the answer, the hexadecimal number. So here we find two numbers 10 and 13 that does not falls in this. So we have to find the equivalent hexadecimal, equivalent of this 10 and 13. So here in this table for 10 the hexadecimal equivalent is A, and for 13 it is D. So it is A for this and D for this. And in this repeated multiplication method, so we will write the answer from up to down. So here the 8 will be the MSB and 7 will be the LSB. This is the answer. So for the decimal number 0.54, the equivalent hexadecimal is 0.8A3D7. Why I put this 3 dot is here? Because in repeated repeated multiplication method, we have to continue doing the multiplication until the fraction part becomes 0. But in this case the fraction part does not become 0. It keep on going without an end. So at a point we stop the repeated multiplication. So the meaning is there are if we keep on doing the repeated multiplication, more digits will be formed, but we are stopping after 5 digit is formed. So I am using this 3 dots to show that there are more digits that can be formed. Problem 3. Convert the decimal number 178.86 to hexadecimal number. In this number 178 is the integer part and 0.86 is the fraction part. So 178 is solved using the repeated division method and 0.86 is solved using the repeated multiplication method. First, take 178 and divide by 16. The quotient is 11 and remainder is 2. Take the quotient 11 and again divide by 16. You get quotient 0 and remainder 11. So this process continues until the quotient become 0. So here the quotient has become 0. So we stop here. Now from the remainder part we have to find the answer, the hexadecimal number. As everyone knows, the hexadecimal number is a number from 0 to 9 and A to F. So here we have a number 11. So that does not comes in this. So we have to find the equivalent hexadecimal of 11. So from the table we can find for 11 the equivalent hexadecimal is B. So B for 11, and the answer should be written from up to the answer should be written from bottom to up in this form. This B will be the MSB and 2 is the LSB. So this is the answer. For the decimal number 178, the answer is B2. B2 answer is. Now we are going to solve the fraction part of this decimal number using repeated multiplication method. So 0.86 into 16 is equal to 13.5. So here 13 is the integer part and 0.76 is the fraction part. So again take the fraction part 0.76 and multiply it with 16, so you get 12.16. So 12 is the integer part and 0.16 is the fraction part. So repeat this process till the fraction part become 0. In this case, the fraction part does not become 0. It goes on, the number goes on repeatedly without an end. So we'll stop at this position. At this point we'll stop, and we can find the hexadecimal number from the integer part. So here this will be the MSB and this is the LSB. So as I said before, the hexadecimal number will be a number from 0 to 9 and A to F. So here we have a number 13, 12 and 15. So we have to find the equivalent hexadecimal of these numbers. So we'll use the table. So for 13 it is D, and for 12 it is C, and for 15 it is F. So the answer, you have to write it in from top to bottom way. This is the answer. So for 13 it is D, and for 12 it is C, and for 15 it is F. So the answer is point D, D, C, 2, 8, F. Now we solved the integer part and the fraction part, and we got the hexadecimal number. This is for the integer part 178, and this is for the fraction part 0.86. Now we have to combine these two answers what we got and to get the equivalent hexadecimal number. So the final answer will be so we are adding B2 plus 0.DC28F. So the answer, final answer is this one.